Hello and welcome. Today I will be answering Waec 2017 Physics Theory question number 1. The question says a particle is dropped from a vertical height and falls freely for a time t. With the aid of a sketch, explain how h varies with t squared. Okay, so let's begin with the graph of the vertical height against the time. The vertical height in meter is on the y-axis, and then the t squared measured in seconds is on the x-axis. Okay, now let's also have the origin of the graph 0 0. So the graph, the sketch shows that the height decreases heavily with time. So the graph shows that the height decreases heavily with time. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafrican.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 Physics Theory question number 2. The question says a particle is projected horizontally at 15 meters per second from a height of 20 meters. Calculate the horizontal distance covered by the particle just before hitting the ground. Now the question requests us to calculate the horizontal distance covered at a time t. Now the horizontal distance is also referred to as the range. Okay, so there are two ways of solving this problem. Now let's first of all look at the diagram. Let's look at the diagram. Let's have the height. The height is 20 meters, and then it's projected. Okay, and here we have the range, which is the horizontal distance that we want to look for. Now here, this is the horizontal velocity, which is 15 meters per second. Okay, so now here the initial velocity here is equal to 0. All right, now using the formula h equal to ut plus half gt squared, but u is equal to 0, so we are left with h equals to half gt squared, which is equal to 1/2 times 10 times t squared. Of course, we have the height to be 20, equals to 1/2 times 10 t squared. So here we have 20 equals to 5t squared. We have 5t squared is 2 seconds. Now the range is equal to u times t. that is the horizontal velocity, which is equals to 15 times the time, which is 2. The final answer is going to be 30 meter. So the range, which is the horizontal distance covered at the time t, is 30 meter. But or we can use the relation that says range is equal to u times the root of 2h over g, and here we have 15 times, we have 2 times 20 over 10. This will give us 15 times root 4, which is 15 times 2, which is equals to 30 meter. So whichever formula you prefer to use, whether to use h equals to ut plus half gt squared, or you decide to use the range equals to the horizontal velocity times the root of 2h over g, you will get the same answer. So the horizontal distance covered by the particle at the time t is equal to 30 meter. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 Physics Theory, question number 3. The question says list 3 phenomena which can be explained by molecular theory of matter. Now matter is anything that has space, that has mass and occupies space. Alright, so the phenomenon that can be used to explain molecular theory of matter are: number 1, let's have number 1, osmosis, number 2, viscosity, number 3, diffusion, number 4, we have Brownian motion, and we can also have number 5, capillarity. So all these are phenomena that can be used to explain molecular theory of matter. Thank you. For more videos, I'd like you to subscribe to our YouTube channels, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 Physics question 4. A spiral spring has a length of 14 cm when a force of 4 Newton is hung on it. A force of 6 Newton extends the spring by 4 cm. Calculate the unstretched length of the spring. Alright, from Hooke's law, we have F1, over E1 is equal to F2 over E2, but E1 is equal to L1 which is also equals to the original length. So that means that we have E1 equals to L1 minus the original length. So substituting, we have F1 over L1 minus L2, L0, equal to F2 over E2. This will give us 4 over 14 minus the original length is equal to 6 over 4. So we have, if you cross multiply, we have 6 into 14 minus original length equal to 4 times 4, which is equal to 16. So we have this will result to 16. This will give us 84. If you open the bracket, you have 84 minus 6 equals to 16. And then let's come here. We have 84 minus 16 equal to 6 L0. So this will give us 68. To give us 68 equal to 6 I0. So if you divide both sides by 6, the original length will give us 11.33 centimeter. So we have been able to calculate the unstretched length of the spring. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics theory question number 5A and 5B. Now 5A says state two factors on which surface tension depends. Now B says how can mosquito larvae be made to sink in stagnant water? Now first, what is surface tension? It is a force that acts on the surface of a liquid that make the liquid to act like an elastic skin. Now what are the factors that can that the surface tension depends upon? Now number one we have the purity of liquid. Number two, we have temperature of liquid, and then number three, we can have the type or the nature of liquid. Okay, so all these are the factors that surface tension depends upon. Now the B part of the question says how can mosquito larvae be made to sink in stagnant water? Now mosquito larvae can be made to sink by the addition of any of, let's begin with number one, any of detergent or soap. Number two, alcohol. Number three, heat. And number four, we have camphor. All right, so all these items can make a mosquito larva to be made to sink in a stagnant water. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 Physics Theory question number 7. The question says to list the 3 advantages of PN junction diode over diode valve. Now we all know that a PN junction diode consists of a p-type and n-type semiconductors in contact. A PN junction diode acts as a rectifier like the thermionic diode. Okay, so let's begin to list the advantages. Now the first advantages we are going to look at is that PN junction diode is not bulky. Number 1, PN junction diode bulky. Number 2, PN junction diode does not need time to warm like the diode valve. Then number 3, the PN junction diode is cheaper to manufacture in large quantities. And then lastly, number 4, the PN junction diode needs low voltage to operate. So these are the advantages of PN junction diode over the diode valve. Number 1, the PN junction diode is not bulky. Number 2, it does not need time to warm. Number 3, the PN junction diode is cheaper to manufacture in large quantities, unlike the diode valve. Then the PN junction diode needs low voltage to operate. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I'll be answering Waec 2017 Physics Theory question number 8A. The question says to state 2 deductions that can be made from a displacement time graph. Now let's have a typical displacement time graph. Now let this be the time measured in seconds, and then here we have the displacement measured in meter. Let's have the origin, and then let's have a displacement of the graph. Now we can have this. Now and so on. Now the first deduction we can make from this graph is that there's uniform velocity. Number two, there's instantaneous velocity. And lastly, that we can deduce from the graph, there is initial displacement. There's initial displacement. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics question number 8C, and the question says to state two factors that affect the maximum height attained by a bullet fired from a gun. Now, before we state the two factors that affect the maximum height attained by a fired bullet from a gun, it is important to define what maximum height is. Maximum height is the maximum vertical distance that is attained from the point of projection. Okay, so I want to outline the factors that affect the maximum height of a bullet. Now I have more than two. So the first is initial velocity. Initial velocity. Initial velocity. Then number two we have acceleration due to gravity. Then number three, we have air resistance. And then number four, we have angle of projection. Number four, angle of projection. Okay, so these are the factors that affect the maximum height attained by a bullet fired from a gun. The first one I said is the initial velocity or speed. Secondly, it is the acceleration due to gravity. And thirdly, it is air resistance. And then lastly, angle of projection. Now, for more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics question 8D. The question says state two practical examples of mechanical resonance. Now it is important for us to know what resonance are. Resonance is said to occur in an AC series circuit when the maximum current is obtained from such a circuit. So resonance is said to occur in an AC series circuit when the maximum current is obtained from such a circuit. So what are the two practical examples of mechanical resonance? Now let's begin with the first one. Number one, we have shattering. Shattering of glass due to high pitch note, due to high pitch note. Due to high pitch notes. 2. Throwing of 2 paper rider from a vibrating stretched. Then we also have number 3, car bodies rattled at very high speed. Then we also have number 4, collapsing of a bridge by matching soldiers. So these are the practical examples of mechanical resonance: shattering of glass due to high pitch notes, throwing of 2 paper rider from a vibrating stretched, car bodies rattles at very high speed, collapsing of a bridge by matching soldiers. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, Educate, www.educateafrican.com. Thank you. Hello, welcome. Today I will be answering Waec 2017 Physics question number 8E, and the question says a body is released from rest at the top of a plane inclined at 30 degrees to the horizontal and 4 meter high. If the coefficient of friction between the body and the plane is 0.3, calculate the time the body takes to reach the bottom of the plane. Alright, so let's quickly have a diagram of the plane. So here we have 30. Okay, so let's find acceleration. Equal to g sine theta acceleration is equal to 10 times sine 30 minus 0.3 times 10 times cos 30 degrees, which is equal to 10 times 0.5 minus 0.3 times 10 times 0.8660. So we have 5 minus 2.598, which is equal to 2.4 meter per second squared. Alright, so let's look for the distance covered. The distance covered is equal to, from the plane, 4 over sine theta, which is 4 over sine 30, which is equal to 8 meter. Okay, so using S equals to UT plus half AT squared, we have 8 equals to 0 times T plus 1 over 2 times acceleration, which is 2.4, we got that earlier, times T squared. This is 8 equal to 1 over 2 times 2.4 T squared. So we have 8 equal to 1.2 T squared, then T squared is equal to 8 over 1.2, and that will give us 2.58 seconds. So the time taken for the body to reach the bottom of the plane is 2.58 seconds. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com, for more videos. Thank you. Hello and welcome. Today I'll be answering Waec 2017 physics question 9a. The question says to define stable equilibrium as applied to a rigid body. Now, a body is said to be in equilibrium if it tends to return to its original position after being slightly displaced. So I define that again. A body is said to be in stable equilibrium if it tends to return to its original position after being slightly displaced. So a body is said to be in stable equilibrium if it tends to return to its original position after being slightly displaced. So an example is a ball in a bowl. Another example is a cone with its base facing the ground. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. And welcome. Today I will be answering Waec 2017 physics question number 9b. The question says sketch a block and tackle system of pulleys with a velocity ratio of 3. So right away we just draw from here. Just a rough sketch. It might not be drawn to scale, but this is the way it looks like. So we have so let's continue. We have another one. That means the velocity ratio is equal to the number of pulleys in the system. The number of pulleys in the system, that is VR is equal to 3. So we've been able to sketch a block and tackle system of pulleys with a velocity ratio of 3. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics question number 9c. The question says, at the beginning of a race, a tire of volume 8 times 10 raised to power minus 4 meter cube at 20 degrees Celsius has a gas pressure of 4.5 times 10 raised to power 5 Pascal. Calculate the temperature of the gas in the tire at the end of the race if the pressure has risen to 4.6 times 10 raised to power 5 Pascal. So let's begin by writing out the parameters that we have. So beginning with P1 equal to so let's have P1 equal to 4.5 times 10 Pascal, and then let's have P1 P2 equals to 4.6 times 10 raised to power 5 Pascal, and let's have T1 equal to 20 degree, now plus 273 is equal to 293. Okay, and then T2 is unknown. Now using pressure law, we have P1 over P2 over T1 equal to P2 over T2. This will be equal to 4.5 times 10 raised to power 5 over 293, which is equal to 4.6 times 10 raised to power 5 over Hello and welcome. Today I will be answering Waec 2017 physics question number 10A. The question says, what is wavefront? Now, wavefront is a surface over which particles vibrate in the same phase. Now, let's begin by saying that wavefront is a surface over which particles vibrate in the same plane. Okay, now we have circular and plane wavefront. Okay, now circular, these are waves. Then we have this is plane wavefront, and this is circular wavefront. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics question number 10B. I in Roman figure and 2 in Roman figure. Question number 1 in Roman figure says, state 2 practical uses of glass prisms. Number 2, list 2 factors that determine the deviation of a ray of light traveling from air into a triangular glass prism. Now, glass prisms are used practically for 1, changing direction of light or changing the direction of dispersion. 2, glass prisms are used in viewing distant objects like the binoculars. Now we also have that the glass prism is used to determine refractive index of a glass. And then number 4, glass prism is used in viewing objects over obstacles. That is talking about periscope. So let's list them. Let's list the two practical uses of glass prism. I've given up to 4, so let's write them out. Factors or practical uses of glass prism. So we have to use glass prism is used in changing the direction of light, or the direction of dispersion. And then secondly, it is used in viewing distance objects. Okay, it is also used in determining the refractive index of glass. Then it is also used in viewing objects over obstacles like the periscope. Okay, so these are the practical uses of glass prisms. Okay, now the second question says list 2 factors that determine the deviation of a ray of light traveling from air into a triangular prism. Now let's assume let's draw the interface, and then let's have the incidence, and then the angle it makes with the interface, and then here is the incidence. So here we want to consider factors. The factors are: number 1, we have angle of incidence. Number 2, we have refractive index of the prisms. Then number 3, we have the refracting angle, of the prism. Alright, so these are the factors that determine the deviation of a ray of light traveling from air, that is traveling from air. This is from air to glass. Okay, so the first one is the angle of incidence, refractive index of the prism, and refractive angle of the prism. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 Physics question 10C Roman figure 2. The question says the angular magnification of an astronomical telescope is in normal adjustment is 5. If the focal length of the objective is 100 centimeter, calculate the focal length of the eyepiece and then the length of the telescope. All right, so let's begin with the calculation of the eyepiece. A, we have solving for A, magnification is equal to focal length of the objective lens over the focal length of the eyepiece, and then magnification is given to be 5, and then we have focal length of the eyepiece to be 100 over Fe. So making Fe the subject of the formula, we have 100 over 5, which is equal to 20 centimeter. Now that is for A. Then for B, to find the length of the telescope, length of the telescope is equal to F naught Fe, that is focal length of the objective plus the focal length of the eyepiece, which is equal to 100 plus 20. Altogether we have 120 centimeter. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 Physics question number 10B3. The question says to sketch a graph to illustrate the variation of the angle of deviation with that of incidence for a ray of light traveling from air into a triangular glass prism. Indicate on the graph the point at which the angle of incidence is equal to the angle of emergence. Okay, so let's begin with the graph. Now here, this is the deviation, and then this is dm. That is the angle indicating the angle of incident equal to the angle of emergence. So at this point, angle of incident is equal to emergence. So in indicating on the graph the point at which the angle of incident I is equal to the angle of emergence, this is where to indicate. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. and welcome. Today I will be answering Waec 2017 Physics Theory question number 10C, Roman figure 1. The question says to draw and label a diagram of an astronomical telescope in normal adjustment. Now, because of the diagram, I have provided the solution on the screen. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 Physics question 10C, Roman figure 2. The question says the angular magnification of an astronomical telescope is in normal adjustment is 5. If the focal length of the objective is 100 centimeter, calculate the focal length of the eyepiece and then the length of the telescope. All right, so let's begin with the calculation of the eyepiece. A, we have solving for A, magnification is equal to focal length of the objective lens over the focal length of the eyepiece, and then magnification is given to be 5, and then we have focal length of the eyepiece to be 100 over FE. So making FE the subject of the formula, we have 100 over 5, which is equal to 20 centimeter. Now that is for A. Then for B, to find the length of the telescope, length of the telescope is equal to F naught FE, that is focal length of the objective plus the focal length of the eyepiece, which is equal to 100 plus 20. Altogether we have 120 centimeter. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 Physics question number 11A. There are two questions there. The first one says what is dielectric, and the B part, the question number 2 says a parallel plate capacitor consists of two plates, each of area 9.6 times 10 raised to the power minus 2 meters square, separated by a dielectric of thickness 2.25 times 10 raised to the power minus 3 meter and dielectric constant 900. Calculate the capacitance of the capacitor. So first we define dielectric. A dielectric is an insulating material. It could be a liquid, it could be a solid or a gas, separating the two plates of a capacitor. So let's write that out, that a dielectric is an insulating material. It could be solid, it could be liquid or gas, separating the two plates of a capacitor. Okay, so that is dielectric. Now the B part, Now, to calculate the capacitance of the capacitor, we use the relation which is equal to the area over the thickness. Now this is equal to the constant, which is 900 times 8.85 times 10 raised to power minus 12 is given in the question, times 9.6 times 10 raised to power minus 3. Divide all by the thickness. The thickness is 2.25 times 10 raised to power minus 4 is also given. So total capacitance of the capacitor will be 3.4 times 10 raised to power minus 7 farad. So we've been able to solve the problem of the capacitance of the capacitor. Now, for more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics question 11B Roman figure 1. Which of the following devices has a higher resistance, an ammeter or a voltmeter? Give reason for your answer. Now, a voltmeter has a higher resistance. The reason is because a voltmeter is connected in parallel in a circuit to allow passage of minimal current through it. Now, as a result of this, circuit current is not significantly affected. So the voltmeter has a higher resistance. Reasons: because voltmeter is connected in parallel. It's connected in parallel in a circuit. To allow passage of minimal current through it. The circuit current is not affected. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics question 11B Roman figure 2. Now, the question says, according to the diagram, the resistance of the voltmeter in the circuit diagram illustrated above is 800 ohms. Calculate the voltmeter reading. Alright, so let's begin by calculating the resistance, since the resistance are connected in parallel. So we have 1 over R is equal to 1 over 400. That is for resistors that are connected in parallel. 400. This will be R1 equal to 200 ohms. Okay, now for R2 we have 1 over R2, which is equal to 1 over 800. 1 over 800 plus 1 over 800. This will give us, so R2 is equal to 400 ohms. Okay, so the total resistance RT is equal to 200 plus 400. We have a total of 600 ohms. Okay, now let's calculate the current that flows through the circle, which is VT over RT, which is equal to 6. From the diagram, the volt is 6, and then we have 600, which is equal to 0.01 amperes. Okay, now to find the voltmeter reading, the voltmeter reading will be equal to the PD across R2, and that will be equal to 0.01 times 400, and this will be equal to 4 volts. So we've been able to calculate the voltmeter reading. So the voltmeter reading is 4 volts. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics question 11C. Now from the diagram, the question says a battery of negligible internal resistance is connected to a set of resistors as illustrated in the circuit diagram above. Determine the equivalent resistance of the circuit. Now as you can see from the diagram, the first two resistors, there are two resistors that are connected in parallel. So let's calculate for the two resistors that are first of all in parallel. So we have resistors in parallel. So for resistors in parallel, we have, for resistors in parallel, we have 1 over R, 1 over R, 1 over R, 1 over R equal to 1 over R plus 1 over R. Now remember, this is resistor in parallel, which is equals to 1 over 2 plus 1 over 2 is equal to 1. Then the two other resistors, that is this one, is now in in series with the other ones, which is so here we have 2, here we have, this is 2 ohms, here we have 1 ohms, then here we have 2 ohms. So the total resistance or resistance equivalent is 2 plus 1 plus 2, so we have 5 ohms respectively. So we have been able to determine the equivalent resistance of the circle. For more video, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2017 physics question 12a. Question 1, the Roman figure says, what is nuclear fission? Question 2 says, state the function of each of the following materials in a nuclear fission reactor: graphite, boron rods, and liquid sodium. Now first let's talk about nuclear fission. Nuclear fission is the splitting up of a heavy nucleus into lighter nuclei with release of a huge amount of energy and neutrons. Then the functions of graphite in a nuclear fission reactor is that it slows down high energetic neutrons in the reaction chamber. The function of boron rods in a nuclear fission reactor is to absorb excess neutrons so as to control fission rate, and the function of the liquid sodium in a nuclear fission reactor is to extract or conduct excess heat from the reaction chamber. Now just to pull down a few things here. Nuclear fission is the splitting up of a heavy nucleus into lighter nuclei with release of a huge amount of energy and neutrons. Okay, now the function of graphite, the function of graphite is to slow down high energetic neutrons. Then the function of boron rod is to absorb excess neutrons, and then the function of the liquid sodium is to extract or conduct excess heat from the reaction chamber. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you.